At 3:17 a.m., a listening post dug into the collapsing earth near Saint-Lô, France, July 1944. The air is thick with the smell of damp soil, cordite, and distant death. Lieutenant Arthur Vance, U.S. Army Signal Corps, presses a Bakelite headset tighter against his ear. His knuckles are white. He is a man trained to understand signals, but the only ones that matter are the ones he cannot stop. Through the hiss of static, a calm, efficient German voice cuts through. Ziel, Gitter 44B, Feuererlaubnis. A target. Grid 44B, permission to fire. Vance winces, bracing for the inevitable. Seconds later, the world outside the dugout rips apart as German 88mm shells find their mark, landing directly on an American tank destroyer platoon. Vance is not a soldier. He is a radio engineer, a man of circuits and frequencies, assigned to the 120th Infantry. His credentials are a degree in electrical engineering and a near-religious obsession with ham radio. His failure is absolute. He is a watchdog who can only bark. He can hear the German armor coordinating, hear the forward observers correcting artillery, hear the precise, methodical dismemberment of his own forces, but he cannot intervene. The hedgerow country of the Bocage has become a slaughterhouse, and the German Funknetz, their radio network, is the butcher's nervous system. The contrast is agonizing. American units struggle with heavy, unreliable SCR-300 radios, while the German panzers whisper to each other with terrifying clarity. Vance clutches a folded schematic in his pocket, a drawing on standard-issue graph paper. It is his own design, rejected 3 months prior. It is an idea born of desperation, a simple circuit that promises chaos. He sits in the dark, the German operator's voice now confirming the kill. Ziel zerstört. Target destroyed. Vance looks at his own silent transmitter. He isn't just listening to the enemy. He is listening to the empty space between their words. He hears the clean carrier wave, the arrogant confidence of an enemy that believes its communications are untouchable. His mind drifts from the trench, back to his workshop in Indiana, to the night spent chasing faint signals from across the world. The military trained him to think in terms of interception and decryption. But Vance thinks like a tinkerer. You don't just listen to a noisy machine, you find a way to jam it. A strange, heretical thought that began as a frustrated doodle now solidifies in his mind. What if the goal isn't to decode the German signal? What if it isn't to pinpoint the one frequency they are using at that exact second? What if, instead, you just destroyed the entire spectrum? What if you drowned them, not with artillery, but with noise? A tidal wave of pure electronic static, so loud and so broad that no signal could survive. He remembers the confusion on his superior's face when he first proposed it. You want to... what? Just make noise. The dismissal was immediate. It was seen as crude, imprecise, a brute force solution in an emerging science that prided itself on surgical precision. We are a scalpel, Lieutenant, the colonel had said, not a sledgehammer. Vance stares into the darkness, the radio buzzing in his ear. He knows a scalpel can't stop a tank battalion. What he didn't know was that this ridiculous sledgehammer, this electronic ghost, would soon change the war. The problem, as outlined in War Office memos from 1943, was one of terrifying efficiency. The German Wehrmacht had integrated tactical radio communication into its core blitzkrieg doctrine. Field reports from the North Africa campaign were analyzed by a stunned Allied command. The German Funknetzer was not just a tool, it was a weapon. Every Panzer IV and Tiger tank, every Stuka dive bomber, every forward artillery observer was linked. They operated as a single multi-ton predator. The standard Wehrmacht tank radio, the Fugi 5, operated on a predictable band between 27.2 and 33, 3 megahertz. This standardization was its greatest strength, allowing seamless coordination between armor, air, and infantry. Allied efforts to counter this network were, by 1944, proving tragically inadequate. The focus of Allied signal intelligence was strategic. The high-level work at Bletchley Park was brilliant, breaking the Enigma ciphers used by German High Command. But that information took hours or days to filter down. It couldn't stop a tank commander from correcting artillery fire right now. The tactical problem remained. Allied spot jamming attempts were a failure. A German radio operator, facing interference on one frequency, would simply turn a dial, ordering his network to schalten or switch to a prearranged alternate channel. It was a game of electronic whack-a-mole, and the Allies were losing. An after-action report from the 120th Infantry, dated July 10, 1944, stated it plainly. Enemy radio discipline is absolute. Corrections for artillery are issued and confirmed in under 30 seconds. Our own signal security is frequently compromised, while theirs remains effectively immune. We are losing the electronic war in the hedgerows. This data was not abstract. A 30-second correction window was the exact time it took for a hidden ATTE Mitters anti-tank gun, guided by a concealed forward observer, to acquire, fire and destroy an American M4 Sherman. That statistic was the flash of an explosion, the smell of burning diesel and ammunition. It was the concussion that rattled the teeth of men 100 yards away. It was the sight of a 30-ton tank, a symbol of American industrial power, brewed up and blackened, its crew victims of a conversation they couldn't hear. The human cost was written in the faces of the survivors, the exhaustion, the bocage fever, the sudden paralyzing fear that every time their own radio crackled to life, a German listener was triangulation their position. Morale in the frontline units was cracking under the strain. The problem was discussed in the highest echelons. Engineers at the MIT Radiation Laboratory and the British Telecommunications Research Establishment were focused on high-altitude, high-frequency radar, the wizard war of night fighters and V-rocket detection. Jamming a simple, robust, low-band tactical radio network was considered a secondary and perhaps impossible task. The spectrum was too wide, the transmitters too numerous. The official consensus was that efficient, widespread jamming of ground force communications was not feasible. The experts agreed it couldn't be done. This wall of impossibility is what defines wartime innovation. If you find these hidden histories of technology compelling, stick with us. The solution was simpler and more absurd than anyone imagined. Arthur Vance was an unlikely officer. He was 28 years old, a skinny, bespectacled man from Terre Haute, Indiana, who had spent his entire youth hunched over glowing vacuum tubes. His call sign, W9V, was better known in the Midwest ham radio community than his own name. He had built his first transmitter at age 12, scavenging parts from a burned-out phonograph and a Model T spark coil. For Vance, the ether was not empty space. It was a landscape. He didn't just talk. He tinkered, he listened, he probed. He loved the noise floor, the cosmic static that most operators tried to filter out. To him, this hiss was the sound of the universe, a canvas waiting for a signal. He hadn't been drafted in the traditional sense, a talent scout for the Office of Strategic Services, or OSS, had flagged his name after intercepting a paper he'd written on harmonic signal propagation. He was shuffled unceremoniously to the signal corps, where his quiet, academic nature clashed immediately with the rigid military hierarchy. Vance didn't understand parade ground discipline, but he could read a circuit schematic like a novel. He saw the complex, hierarchical German Funknetz not as an impenetrable military fortress, but as a poorly designed broadcast network. It was loud, it was centralized, and its operators were lazy. They stayed on the same channels. They used too much power. It was, in his estimation, a system just waiting to be crashed. The idea crystallized in a damp briefing tent in Aldbourne, England, 2 months before the invasion. He had requested a meeting with his commanding officer, a career-oriented colonel from West Point. Vance unrolled his schematic on a folding table. It was laughable in its simplicity. It wasn't a receiver. It wasn't a decoder. It was just a noise generator, a simple oscillator circuit, a cheap amplifier, and a rudimentary antenna. It was designed to be powered by a battery stuffed in a can and dropped from a plane. "Colonel," Vance began, his voice barely audible over the rain, "it doesn't talk to them. It screams at them, across their entire tactical band. It's a noise bomb." The colonel stared at the drawing, then at Vance. "Lieutenant, we are engaged in the precise interdiction of enemy assets. We are developing radar countermeasures that cost $50,000 apiece. You are proposing throwing electronic mud at them. What if this noise bomb hits our own communications?" Vance tried to explain. "It won't, sir. It's low power, short range and battery operated. We drop it on them. It just blankets their local grid. It's a carpet jammer." The colonel folded the paper and handed it back. "That's the most ridiculous brute force piece of engineering I've ever seen. We are not funding a high school science project. Get back to your antenna maintenance, Lieutenant." Dismissed. Vance took the schematic. He was dismissed, but he was not defeated. He would build it himself. His secret workshop is a requisitioned stone barn near Greenham Common Airfield, miles from the prying eyes of headquarters. The place smells of damp hay, axle grease, and ozone. His ally is a man who doesn't care about regulations. Staff Sergeant Mike Solder Kowalski. A pre-war telephone lineman from Chicago, Kowalski possesses the invaluable military skill of acquisition. He can get anything. "You need 6L6 tubes, Artie," he'd say. "I know a guy in the motor pool who's got a crate off Manifest." They work by the light of a single bare bulb, their project hidden under a pile of greasy tarpaulins. The planning is done on the back of ration boxes. They borrow parts from the motor pool, salvaging oscillator tubes from damaged radar sets that were meant to be scrapped. Batteries are acquired from a downed B-17. The prototype is constructed inside a standard 50 caliber ammunition can. It is ugly, heavy, and dangerous. The wiring is a rat's nest of insulated cable and bare metal solder joints. The sensory detail of their work is one of forbidden tension. The high-pitched whine of the oscillator warming up, the sharp smell of hot metal and melting wax insulation. They are violating at least a dozen articles of the Uniform Code of Military Justice. A formal log, written in Vance's neat script, details the build. Prototype log, carpet eye components, 2 6L6 beam power tubes, 1 crystal oscillator, salvaged German make. Power source 24 VDC battery pack. Casing M2A1 ammo box. Estimated broadcast range 3 to 5 miles. Estimated battery life 45 minutes. The test is conducted at 0200. On a wooden bench sits the ammo can. Next to it is their control, a captured German Torn EB receiver tuned to a known Panzer frequency. Kowalski checks the barn door. Clear. He nods to Vance. Vance wipes his sweaty palms on his trousers and throws the heavy knife switch he wired to the battery pack. There is a pop. A flash of blue light from one of the tubes and the acrid smell of a fried resistor. The ammo can goes silent. On the German radio, the faint hiss of the open channel remains. Kowalski lets out a string of curses. Fried the main cap, Art. Pushed it too hard. 2 hours later, they are ready again. A new capacitor, acquired from the ignition system of a command jeep, is soldered crudely in place. Again, Vance says. He throws the switch. This time, the lights in the barn dim for a heartbeat. The ammo can begins to hum, a deep, resonant, vibrating drone that seems to shake the dust from the rafters. And from the speaker of the German radio, a sound erupts. It is not static. It is a deafening, tearing, mechanical roar. It is the sound of 1,000 demons screaming. It is the sound of the spectrum itself being ripped apart. Kowalski instinctively claps his hands over his ears. Vance, however, is grinning, his face lit by the glow of the tubes. He grabs the dial on the German receiver and twists it. The shriek is everywhere. 27 megahertz, 30 megahertz, 33 megahertz. The entire tactical band is gone, completely obliterated by their electronic monster. Vance turns off the switch. The sudden profound silence is more shocking than the noise. Kowalski lowers his hands, his eyes wide. My God, Artie, you killed the radio. The unauthorized test does not go unnoticed. A report lands on the colonel's desk from the 101st Airborne, whose command post was conducting a training exercise 3 miles from the barn. They reported a catastrophic failure of their own command net, a net that, unbeknownst to the colonel, was using captured German equipment. Vance is summoned to the field HQ near St. Lo. He stands at attention, mud on his boots, in a tent that smells of canvas and cigar smoke. Lieutenant Vance, the colonel begins, his voice dangerously calm. I have a report from the 101st. They found an ammo can that blacked out their command net for nearly an hour during a live-fire exercise. Explain yourself. Vance feels Kowalski's nervous energy behind him, but his own voice is steady. Sir, that was an unauthorized systems integrity test. The colonel's eyes narrow. Unauthorized. You jammed a command frequency during wartime. You interfered with an airborne unit. I could have you court-martialed and shot. There is a long silence. With respect, sir, Vance says, it worked. The 101st net was down because they were using captured German gear at that checkpoint. My device only targets the German frequency bands, just as I designed it. It did exactly what it was supposed to do. It was a success. The colonel stands up, walking over to a large operations map covered in acetate. You were given a direct order, Lieutenant. You were told it was ridiculous. Vance takes a breath. This is the moment. Sir, we are losing men every hour because their 88s are talking and ours are not. We are sitting here with maps, trying to guess where they are, while they know where we are. I can make them deaf. I can make them blind. I can put their observers and their tanks in the same darkness we're in. That's not ridiculous, sir. That's a weapon, a cheap weapon. Give me a C-47 and a dozen of these, and I can silence a panzer division. Let me build 10. Let me drop them ahead of the next push. What exactly do we have to lose? The colonel stares at the map, at the red arrows of the German counterattacks. The ridiculous idea now has a tactical purpose. The real test comes during Operation Cobra, the Allied breakout from the Normandy beachhead in late July 1944. The order is given. Project Carpet is a go. Vance and Kowalski, their eyes raw from 72 hours of non-stop work, have assembled 20 of their noise bombs in the barn. They are loaded onto a C-47 transport plane, flying low and fast over the shattered landscape south of St. Lo, directly toward the massing armor of the Panzer Lehr division. Vance, his static line clipped to the anchor cable, stands by the open door. The carpet units, attached to small, crude parachutes, are shoved out into the pre-dawn darkness. The scene cuts. A German command half-track, antennas bristling, sits half-hidden in a cluster of trees. A Hauptmann, a company captain, is shouting into his microphone, trying to coordinate a counterattack. Panzergruppe, report, status, sofort. Immediately, he slams the side of his torn E.B. He said nothing. The speaker, which moments before was alive with the voices of his platoon leaders, now emits only the deafening, soul-shattering roar. Cut to the turret of a Tiger tank. The commander hammers his headset. It's useless. He is blind, cut off from his observers, from his chain of command. Cut to an American forward artillery post. The observer peers through his binoculars. Fire mission on grid 44B. The targets they're disorganized. They're driving in circles. I see no coordinated return fire. Repeat, no coordinated return fire. The German counterattack, which was meant to be a swift, decisive blow, dissolves into chaos. Panzer units cut off from their radio net drive blindly into American tank destroyer traps, the dreaded 80mm batteries. Their fire control networks jammed by the carpet are slow to respond, their fire inaccurate and sporadic. The impact is quantified in the after-action reports. After-action report, 30th Infantry Division, 28 July 1944. Enemy armor resistance was 70% less effective than predicted. Prisoners of war reported total and catastrophic communications failure. It was like the sky was screaming, one captured NCO stated. Back at the command post, the colonel finds Vance sleeping on a pile of signal wire. He doesn't say thank you. He doesn't apologize. He just drops a new requisition form on Vance's chest. Authorization for 500 units. Project Carpet. Don't make me regret this, Lieutenant. The immediate consequences are profound. Project Carpet and its official, mass-produced counterparts like the AN/APT-2 jammer are rushed into service. The ridiculous idea becomes doctrine. B-17 Flying Fortresses and RAF Lancasters are soon retrofitted with powerful jamming suites, airborne versions of Vance's ammo can, designed to blind the sophisticated German Würzburg and Liechtenstein air defense radars. The term carpet becomes the official Allied designation for radar jamming systems. The Wizard War is no longer just about radar, it's about counter-radar. The Wehrmacht's technological edge, its nervous system, is systemically blinded. In the long term, Vance's brute force approach becomes the foundation of modern electronic warfare, or EW. The idea of spectral dominance, that victory belongs to the side that controls the electromagnetic spectrum, becomes a central pillar of 21st century military doctrine. The ridiculous idea of just screaming into the void is refined. It evolves into sophisticated barrage jammers, smart noise that can mimic enemy signals, and deceptive electronic signals designed to create phantom armies. Arthur Vance is never famous. His name, if it appears at all, is a footnote in a classified Signal Corps technical annex, declassified decades later. After the war, he is honorably discharged. He returns to Indiana, opens a small radio and television repair shop, and resumes his life as W9V. His neighbors know him as the quiet, patient man who can fix anything. They have no idea that the high school project he built in a barn saved thousands of lives and helped win the war. Today, the battle Arthur Vance started is fought every second all around us. It is not waged with vacuum tubes and ammo cans, but with complex algorithms, autonomous drones and satellites, the jamming of GPS signals, the hijacking of drone control feeds, the cyber warfare that targets a nation's power grid. It is all the legacy of Project Carpet. The electromagnetic spectrum is the new high ground. The air we breathe is not empty. It is a battlefield, filled with the invisible signals that power our modern world. The greatest innovations are rarely the most complex. They are often simple, elegant, ridiculous solutions to problems that experts deemed impossible. They are acts of defiance, born of desperation and insight. The damp, muddy dugout at St. Lo is long gone, filled in by time. The barn at Greenham Common has been replaced by a supermarket. But the principle endures. The silent static that Vance heard in his headset is still there, a digital ocean, waiting for the next tinkerer, the next ridiculous idea to rise above the noise. Every great idea begins as an act of defiance against impossibility. What impossible ideas do you think could change the world?